Hello, everyone, and welcome back again to our channel, Tutoring Made Easy. I hope each and every one of you is doing great. The goal of this channel is to make tutoring very easy and enjoyable. Please, if you haven't yet subscribed to our channel, we would like you to do us this great favor by subscribing so we can grow this family together. If you've already subscribed, thank you so much for supporting us. On the other hand, if you have specific tutoring topics you would like us to do a video on for you, we'll be more than willing to do that. Maybe there are topics on math, special topics on physics, statistics, chemistry, economics. Uh, Let us know. Drop it in the comment section and we'll be more than willing to do that just for you. In today's video, we shall be looking at mathematics, and it's on the topic, the rules of differentiation. Remember, in our previous video, we went through the concept of calculus, and we looked at the differentiation side of the calculus. We did state the rules of differentiation, but we didn't actually go deeper into it. And remember, we did mention that calculus is credited to Sir Isaac Newton, also known as the father who invented gravity, the one who invented gravity and the father of physics. Today, we're going to be looking at the rules of differentiation in detail. Remember, the first rule says that if we have y, I don't know whether you remember, y equals to a multiplying x to the power of n, we give the rule, but I want us to go into how we arrive at that. Now, to be able to do that, we say that our y prime, which is the first derivative or the differentiation of y with respect to x, dy dx, is equal to taking the a and multiplying it by the power n, and then also taking 1 away from the power n. So it's a times n multiplied by x to the power of n minus 1. So therefore, our y prime, which is dy dx, is eventually a n multiplying x to the power n minus 1. That was the first rule. Now, let's look at our second rule. Let's look at the second rule for a second. The second rule says that if you have y and it's equal to a, and we differentiate it, if we differentiate it, we should get a 0. We said that if you take y prime, which is dy dx, of the constant, we should get 0. But how are we arriving at this? That's the question. So let's imagine again that we have y equals to maybe a. Remember, this a can be rewritten. We can rewrite this a as y is equal to a multiplied by, we're multiplying it by x to the power of 0. Why x to the power of 0? Because remember, x to the power of 0 is 1. From indices, we said that if we have anything, to the power of 0 is 1. So because of that, we can rewrite this, our y, we can rewrite the y as a multiplied by x to the power of 0. And that y is equal to a multiplied by 1. Therefore, our y is equal to a. So if that's the case, then we can say that our y, which is equal to a, is the same as our y being equal to a multiplied by x to the power of 0. And if that's the case, our y prime eventually, our y prime or our dy dx is going to be a, we are going to use the first rule, a multiplied by the 0, the first rule, remember the first rule, times the x to the power of 0 minus 1. And that's going to give us y prime, which is dy dx, is going to be, I'm writing it again, a multiplied by 0, x to the power of 0 minus 1. And that's going to give us 0 multiplied by x to the power of negative 1. Now remember that when we multiply 0 by anything, it's actually 0. So we have y prime, which is equal to dy dx, is going to give us 0. So that's why when we differentiate a constant, we get 0. So I hope this is clear. If it's not, please pause the video, go back a little bit, and you see that everything is going to come to you very clearly. So we are done with the first two. Now let's take a look at the third one. The third one is known as chain rule. Third one is known as the chain rule. Chain rule. All right. Now let's imagine for a second that we have y, a function y, which is x plus 5 to the power to the degree of 3. Y is equal to x plus 5 to the power of 3. Now the first thing we can do is to say we will let u represent the x plus 5 without the exponent. And that should be equation 1. Let's name that thing equation 1. Let's say this is our equation 1. This is our equation 1. And then we are going to differentiate this equation 1. The moment we have our equation, we are going to differentiate it. So to differentiate this, we're basically going to have du, okay, let me use this color. We're going to have du over dx is equal to what? Remember this to the power 1 here. And there's some invisible 1 here. So we're going to have 1 multiplied by the 1. We're using the first rule of differentiation. And we're multiplying by x to the power 1 minus 1 plus the 5. It's going to multiply. Remember the 5 is the same as 5 multiplied by x to the power 0. Because this is 1, it's going to give us 5 times 1 and we get 5. So we can write that as 5 multiplied by x to the power 0. But we're going to multiply the 5 by the 0. We're using the first rule. And then we're going to take 1 from the exponent of the 0, which is going to be 0 minus 1. And because of that, we end up getting du dx to be equal to 1x to the power 0 plus 0 to multiplied by x to the power negative 1. And eventually we are getting du dx to be equal to 1, because this is 1. We're going to get only 1, like that. And this goes to 0. This goes to 0. So we can name this equation, this du dx, we can name it as equation 2. We can name it as equation 2. Now, remember that because we did say that because we said that u is equal to x plus 5, then our y should be equal to what? Our y, remember our y is giving us what? X plus 5 to the power 3. Remember that? So because of that, then our y is going to be equal to u, because this is u. It's going to be u to the power of 3. And if that's the case, we are going to name which one? We're going to name, we have our y to be equal to u cubed, or u to the power of 3. In this case, we are going to differentiate. We are going to differentiate this y is equal to u cubed. So what do? We're going to have y prime, we're going to have dy du. We're going to have dy du, because we are going to differentiate y. So we're going to have dy du to be equal to 3 multiplied by 1 multiplied by 3. Why? Because there's an invisible 1 here. We're multiplying, the u cube is the same as 1 times u to the power of 3. So it's going to be 1 times 3 u to the power 3 minus 1. So that's what we are doing, u to the power 3 minus 1. And then eventually, we are going to get 3u squared. We're going to get 3u squared. We're going to get 3u squared, which is going to give us 3u squared. And this will be equation 3. That is going to give us our equation 3. Now, you remember, we said that using chain rule, so we'll say using chain rule, we know that our y prime, which is the first derivative, dy dx, is the same as dy du multiplied by du dx. That's what we stated in the previous video. And we can see that this dy du is our equation 3. And this du dx is our equation 2. Can you see that? I hope you do. Now, it eventually means that our y prime, which is equal to dy dx, is eventually going to give us dy du, which is equation 3, which is 3u squared, multiplied by du dx, which is equation 2, which is this one. And that gives us 3u squared. Now remember that our u, we can say that from equation 1, from 1 u is equal to x plus 5. So let's make this equation here, let's make this equation here 4. From 1 u is equal to x plus 5. So therefore, we can put equation 1 into equation 4. And to do that, we are going to get, when we do that, we're going to get our y prime, which is in equation 4, is going to be dy dx is equal to 3u squared, which is the same as 3 into the u, which is from equation 1, as x plus 5 all squared. Can you see that? Yes, I hope you do. So eventually, we have our final result. Therefore, dy dx, after using chain rule, is 3 into x plus 5 all squared. That is how to use a chain rule. I hope this helps. I'd like to end here. I will come another time. In the next video, we will be solving questions related to chain rule. But you know what? I have another thought. Let's keep going. I'm going to continue with the other rule, which is product rule. So let's look at product rule real quick, so that in the next video we can do more questions. So the fourth rule is product rule. In product rule, in the previous video, we said that the y prime, which is dy dx, was u dv dx plus v du dx. This is what we established in the previous video. So we are going to imagine that we have two functions. We're going to imagine that we have what? We have two functions. Let's say the function we have is y is equal to x plus 2, and it is multiplying x plus 5. So let's imagine this for a second. Now here, we can let u be equal to x plus 2. And then immediately we can name that as our equation 1. And remember, the first thing we do is to differentiate it. So to differentiate this, we have du dx is equal to 1, because you have 1. When you differentiate this, you get 1 right here. It's x to the power 1. If you differentiate, it's going to be 1 times 1, because this is the same as 1 times x to the power 1. So this 1 will multiply this 1, and then x is going to be 1 minus 1, and we get 1x to the power 0, and this is 1. So 1 times 1 is 1. So that's why we get 1. So du dx is going to give us 1. The moment we do that, that becomes our equation 2. I hope you can see that. That becomes our equation 2 right there. Also, we are continuing. Also, let v be equal to the x plus 5. And we are saying that we can make that one to equation 3. This way, we have dv dx to be equal to 1, because we have x, which is the same as 1 times x to the power of 1, which is the same as 1 times 1, x to the power 1 minus 1. We get 1 times x to the power 0, which is 1 times 1, which is 1. The 5 there is the same as 5 multiplied by x to the power 0, because this is 1. 5 times 1 is 1. So you have 5, which is the same as 5x to the power 0. We multiply the 0 by the 5 and get x to the power 0 minus 1. But this is 0, so everything becomes what? 0. So we know the 5 is 0. So we have 1 plus 0, which is 1. So dv dx is equal to 1. And that also is our equation 4. That is our equation 4 right there. Our equation 4 right there. I hope that helps. Now, what are we going to do next? We have u as our first equation. We have du dx as our second equation. Let me take it again. We have u to be our first equation. We have du dx, our second equation. We have v as our third equation. And we also have dv dx as our fourth equation. I think it is time for us to plug things in. What do you think? So the next thing we're going to do is to, let's make this one star, is to put equation 1, equation 2, equation 3, and equation 4 into the equation star. And to do this, we're going to have our dy dx, which is y prime, which is supposed to be u, right? Our u is equation 1, which is x plus 2, multiplying the dv. This is our u. Multiplying by dv dx. Where's dv dx? Is equation 4. It's multiplied by 1 plus our v, which is equation 3, as x plus 5, also being multiplied by du dx, which is equation 2, which is also 1. Therefore, we can rewrite, we can say our y prime, which is dy dx, is equal to x plus 2 plus x plus 5. Do you agree? Because if you have x plus 2 multiplying 1, this is going to multiply this, it's going to be x times 1, plus this is going to multiply this, which is going to be 2 times 1. You get this as x plus 2, and we get x plus 2. And same for the x plus 5 multiplying the 1, where 1 will multiply the x. When 1 multiplies the x, we get x. And when 1 multiplies the 5, we get 5. And then we end up getting x plus 5. Now, if we simplify, we get x plus 2 plus 5. X plus 2 plus 5. X plus x plus 2 plus 5. And that gives us 2x plus 7. So therefore, our y prime is going to be equal to 2x plus 7. And there you have it for the rule known as the product rule. Now we're going to look at the last one. Which is the quotient rule. And that rule, it says that if you have the y prime, which is equal to dy dx, is supposed to be v multiplied by du dx minus u dv dx, all divided by v squared. Okay? So we are going to imagine again that we have a function, maybe y is equal to x plus 2 divided by x plus 5. We are saying that the first thing we do is to let our u be equal to x plus 2. And we said that that is going to be our equation 1, remember? That's going to be equation 1. And we said that the moment we do that, we differentiate our du. So we are going to have du dx to be equal to 1. I hope you know how to do that by now. And then we also let v be equal to x plus 5. And that's our equation, that's going to be our equation 3. So that this is equation 2. And we're also going to differentiate again. We're going to differentiate dv dx, and we're also going to get 1. And that becomes our equation what? 4. Now, remember, to combine everything, we're going to plug things in, right? So that we're going to have our y prime, which is equal to dy dx, is equal to the v. The v there is our x plus 5. This v here is equation 3. x plus 5 multiplied by du dx. Our du dx is equation 2, which is 1, minus u. Our u there is x plus 2, is equation 1, multiplied by dv dx, which is our equation 4, is 1. And then we are going to divide everything by v squared. But what is v squared? Our v from equation 3 is x plus 5, and we squared. And then we're going to basically simplify things. So here, we're going to have dy dx is equal to x plus 5 minus x plus 2, all divided by x plus 5 all squared. The top part, we are going to have dy dx is equal to x plus 5 minus x minus 2 all over x plus 5 all squared. This is going to give us x minus x plus 5 minus 2 all divided by x plus 5 all squared. This is going to give us 0 plus 3 divided by x plus 5 all squared. So now we can see that therefore our y prime, which is dy dx, is the same as 3 divided by x plus 5 all squared. I hope everything looks great and you are understanding what we have discussed today. I'd like to end here. Please, if you have not yet subscribed to our channel, please do us a favor by doing so that you can help us grow this family together. If you've already subscribed, we want to say thank you for supporting us. If you have specific topics that you want us to do a video on, please. Topics on tutoring. It can be math, it can be probability, it can be statistics, it can be physics, chemistry, biology, economics, accounting. Please feel free to drop it in the comment section below, and we'll be more than willing to do that just for you. But for now, I'll come to you another time. Take care and bye.